This is a video on using geometry to evaluate a definite integral. The question states, sketch the region whose area is given by the definite integral. Then use the sketch to evaluate it. The definite integral is the integral from 0 to 3 of the square root of 9 minus x squared dx. So we can say that we have y equals the square root of 9 minus x squared as the integrand, and we want to sketch that graph. It might be more familiar if we do a little algebra first. So let's square both sides, and we get y squared equals 9 minus x squared. And if I add x squared to both sides, I get the more familiar x squared plus y squared equals 9. And that's the equation of a circle that's centered at the origin of radius 3. But since y is the square root of 9 minus x squared to start with, square roots always yield a positive number. So we're going to be above the x-axis. Also, the integral goes from 0 to 3. So that means x isn't going to become negative. So we're going to be to the right-hand side of the y-axis. So what we get is a quarter circle. So here's x squared plus y squared equals 9. X is going to go from 0 to 3, and y must be positive. The good news is that a definite integral yields the area under the curve. And the area of a quarter circle is 1/4 of the area of a circle, which is 1/4 times pi r squared. For our circle, the radius is 3, so I can plug in 3, and I get 1/4 times pi times 3 squared. And then I can simplify, and I get that the integral from 0 to 3 of the square root of 9 minus x squared dx is equal to 9 pi over 4. And I'm done with the problem.